What do you think is the resolution of the video that you're watching right now? Can you tell me? Well, whenever you watch videos online, you have the option to change the video quality to something like 720p, 1080p, 540p, something on those lines. Let me show you one example. This happens usually in most online platforms where you watch videos. So here are two of my friends teaching Photoshop the same lesson in Italian. Stefano and Simone, great people, awesome friends. So as you can see, I'm playing back the video. You have a couple of options right here. If you click on the gear icon right there, you have the option to change the video quality. As you can see, 1080, 720, 540. Now what does that exactly mean? Let's say you're watching this video in 1080p. What does that mean? Well, it just means that along the height of the video, there are 1080 pixels. That's pretty much it. How many pixels do you think are there along the width of the video? Can you tell me? Before we get into that, we need to understand the concept of aspect ratio. So what is aspect ratio? Simply put, aspect ratio is the ratio between the width and the height of an image or a screen. Let me explain. So let's say this is an image or a screen with a width W and a height H from there to there. So the aspect ratio would be width by height. Makes sense? Now let's assume this is a square. So for a square, let's say the width is 5 units and the height would be the same because this, my friend, is a square. So let's set the height to 5 as well. Then the aspect ratio would be 5 by 5, which is 1, right? We can also write it as 1:1. Now let's go for complex numbers. What if this is not a square? What if it's a rectangle? And along the width, you have 3840 pixels, and along the height, you have 2160 pixels. Then the aspect ratio would be 3840 by 2160. Now we need to reduce the numbers. So let's cancel out the zeros. 216 half would be 108. 384 half would be 192. And then if you reduce it even more, 12, if you multiply 9 by 12, you get 108. And if you multiply 16 by 12, you get 192. So we can write the aspect ratio as 16:9. Makes sense? Now if you want to divide it further, you can do that too. So if we divide this further, we would get 1.7777, something like that. So let's write it as 1.78:1. It's the same thing. If you divide 16 by 9, you would get this number. So you can write it as 1.778 or 1.78:1. That's correct too. But if you don't want decimals, this is a better way to write it. Most of the videos online and most computer screens have an aspect ratio of 16 by 9. Even this video is 16 by 9. So now we know that this video has an aspect ratio of 16 by 9. Alright. We also know that the height is 1080. So we don't know the width. So we're going to put W in there. And we know the height, which is 1080. So if you have to calculate width, what do you have to do? Simple mathematics. We have done this before. 16 by 9 into 1080. Remember schools? The answer would be, guess what? Don't use calculators. The answer would be 1920. So how many pixels do you think are along the width of the video? We just calculated 1920. But we did a mistake here. Guess what the mistake is? The teachers usually deduct marks for it in exams. Guess what it is? We didn't mention the unit. So this is 1920 pixels. Coming to the very first question of this video. What do you think is the resolution of the video that you're watching right now, assuming that you're watching it in 1080p? And the answer is simple. The resolution of this video is 1920 by 1080. That's how we write resolutions. Now I don't want you to get confused. There are lots of types of resolutions like spatial resolutions, spectral resolutions, temporal resolutions. You don't have to worry about any of that. The only resolution that we are concerned about right now is pixel resolution. And that's what gonna have some significance when it comes to the Photoshop world. So what are pixels and how do they work? Well, we have already discussed this in depth in lesson 1. So if you have not seen it already, please check it out. Pixel resolution can be defined as a set of two numbers. The first number being the width of the picture and the second number being the height of the picture in pixels. So therefore, 1920 by 1080 makes sense now? Sometimes resolution also refers to the total number of pixels. So what do you think is the total number of pixels of this video? Well, what is the formula for the area of a rectangle? Width into height, right? So just multiply 1920 into 1080. The answer would be somewhere about 2,073,600 pixels. In other words, we can say it as 2.07 million pixels, or in other words, we can say 2.07 megapixels, right? Rings a bell? We have already talked about all this in lesson 1. So how does the resolution affect image quality? As we just learned, the more the resolution, the more the number of pixels. And the more the number of pixels, the more information there is. Let me share with you an example. So have a look at this image. This image of an eye has 1 million pixels. And how can we say that? Look at the dimension of the video. 1000 by 1000, multiply that. 1 million pixels or 1 megapixel. Now look at this image. It's the same image. However, the resolution is different. This is 100 by 100 and this one only has 10,000 pixels. So this is just 10,000 pixels and this is 1 million pixels. This has a higher resolution and this one has a lower resolution. Make sense now? So when you have a low resolution image, it just means that it has a lower number of pixels and therefore less information. When you have a higher resolution, it just means that you have more number of pixels, which results in more information. That's pretty much it. Now there is something that we all need to understand by heart, and this is extremely important. And that is, it is never possible, never ever possible to originally, I'm underlining that again, to originally change a low resolution image to a high resolution image. So if you have a low quality, low resolution image, it is just not possible to originally increase its resolution and add details. It's not. You can do a little bit of guesswork, but it's not originally possible. Now keep in mind, we can decrease the resolution because then we are just losing pixels. We are just throwing away pixels. However, when it comes to increasing the resolution, we cannot just simply invent pixels. Of course, there's some guesswork we can do, but it's just not possible to invent the original pixels that we already lost. Think of it like this. Let's say you have a glass of water. We can easily throw away water, reduce the amount of water, but we cannot increase it again. It is just not possible. Of course, you can bring water from somewhere else, but that won't be it. You cannot increase the original amount of water that was already there. You can throw it away, but you cannot increase the water that was already there. Not possible. Now there's one thing you can do, of course. You can just throw little stones in the glass to make it look like the water is to the top, but it's not actually there. So what is the guesswork that we are talking about? Let me ask you again. Is there any way to increase a low resolution image to a high resolution image? To answer that question, you need to answer, is there any way to increase the number of pixels? If so, how? Well, there are some technologies that would guess when you increase the number of pixels, it would guess what pixels would fill the gap by using different technologies. There are various kinds of mathematics and AI available online in different software. Even Photoshop has one of those technologies. So let's say you have this image. And as you can see, this is a very low resolution image. By the way, if you cannot see the pixel grid, you can go to View, Show. Just make sure Pixel Grid is checked. If that is unchecked, the grid won't show up. All right. So View, Show, Pixel Grid. You can keep it turned off or turned on, absolutely up to you. This doesn't have much details. As you can see, this is a very low resolution image. Now, if you go to image size and try to simply increase it. Now the width and the height is 500 by 318, right? So make sure this is clicked so that the aspect ratio is maintained. We already know what aspect ratio is. So let's increase it to 3000 and hit OK. Now have a look. The details have not increased. Of course, the number of pixels have increased, but the way Photoshop has filled in the pixels between it, it's just not increasing the details. And as we learned, originally it is never possible because we have already thrown the water outside of the glass. There is no way we can originally increase the amount of water that was already there. Now let's go back. This is the low resolution image. There are some technologies that can guess a little better when it comes to filling up the pixels in gaps when you increase the size. So let's go to image size again, and this time we're going to use a brand new technology right there. So the technology is in the resampling area. Just make sure resampling is checked, and then you choose preserve details 2.0. Now there's a slider to reduce the noise if you're having to deal with that, but right now we don't need it. Hit OK. Now have a look. This does a better job of guessing the details. Look, it has more details, looks a little more cleaner. Now, of course, there are artifacts here and there, but it is a better technology at guessing the pixels when it comes to increasing the resolution. Now, there are lots of software and online platforms that do it too. Now, I don't promote or recommend any of these softwares. You can try it out yourself. So these are some of the top websites and software that do it. So you can try them yourself, see what is good for you, and see if you need them already. And in most cases, Photoshop is okay. Now I'm just going to demonstrate one of the websites. This is Image Larger, and in no way, shape or form I'm promoting this. So let's upload this image. Let's drop this file right here. And now it's going to ask how much you want to increase the resolution. So I'm going to go ahead and choose 8 times. High grade recommended. That's okay. Let's start it. If it's an artwork, you would choose artwork. If it's a photo, you would choose photo, so on and so forth. But I just kept it at default. It's going to take a few while to upload, to process, to make it available for you to download. So let's see how the results are. There are lots of great websites and software that you can try. See what works best for you. See what's most affordable for you. There are some which are free. You can easily find them with a simple Google search. Some of them offer you 5 free images and different platforms like that. All right, let's go ahead and let me download this. And let's take a look at the result. I'm just going to open it in Photoshop for you. So this is the upscaled image. Let's zoom in and have a look. Have a look. It did a pretty good job as well. A lot of details. Now let's compare it with Photoshop's technology. So I'm going to go to image size, and I'm going to increase it to 3000. What is the resolution which was done here? 4000, right? So let's go for 4000. Image size 4000. Okay. Make sure resampling is checked. Preserve details 2.0. And this is Photoshop's result. And this one is Image Larger's result. Now I can see that there are a lot more details in Image Larger's result, but there are some artifacts as well. Photoshop doesn't have much details, but it has 0 artifacts. Now it comes down to your personal preference as to what you prefer. In most cases, Photoshop would be fine. If you want some more details, if you have a lot of money to spend, you can go with these websites. Some of them are really great, and on some images they do work real good. But in this case, I see a lot of artifacts, but you can judge it for yourself. There's also a lot of details. There are not much details, as you can see in the hair as well. If you look here, there are tons of details. Also, if you look at this skirt right here, I think it's called a skirt. I'm not very sure. I'm so sorry. Forgive me. So there, have a look. This is Photoshop's results. This is Image Larger's results. Just look at the number of details. So what do you prefer? Photoshop looks a little more original with very less artifacts, but not much details. Image Larger has a lot more details, but some artifacts. So it's up to you what you want to choose. All right. So there you go. There are technologies that can increase a low resolution image to a high resolution image, but do keep in mind, it's all guesswork. It is just throwing stones, little stones in the glass to make it look like the water has come up. It is the same amount of water. Whatever pixels we have filled in there in the form of stones are just guessed pixels. And these are the technologies to simply guess the pixels. Now it's time for us to talk about units. But before we jump into that, I have a question for you. How big or small do you think is a pixel? Well, let me rephrase that. In the physical world, how big is a pixel? How many centimeters? How many millimeters? The answer is, it's absurd, because pixel is a digital unit. And centimeters, inches, millimeters, all of these are physical units. Doesn't make sense? Let me try to throw some more light into it. So let's say you have one of those regular phones with a 1080p screen, which means it has a resolution of 1920 by 1080. Let's say the aspect ratio of the screen is 16:9. In that case, that would be the resolution. And again, you have a monitor, a large monitor with a resolution 1920 by 1080, right? Both of those have the same resolution. However, your monitor screen is way bigger than your phone screen. So in the physical world, the pixel size of the phone screen is smaller and the pixel size of the monitor screen is larger. So pixel does not have a physical size, right? Pixel is a digital unit. Makes sense now? I hope it does. Let me show you one more example. So here in our screen, we see this image, right? Let's talk about image. So how big is the image right now? Well, you can take up a ruler and just size in the image, right? And maybe measure the size of 1 pixel. Measured? Now, if I zoom in, the size of the pixel changes. Physically, in the physical world, if you put a ruler on it on your screen, it's different. This clearly shows that pixel is a digital unit. It has no significance in size in the physical world. Now you must be thinking, why are we talking about this? Because we need to learn how to look at digital unit, that is pixel, in reference to physical unit. We need to connect them. Why? For printing purposes, because pages are measured in centimeters, inches, in physical units. And we need to be able to relate pixels to that. Make sense? No? Let me show you one more example. So if we go to File, New, we are creating a brand new document, right? If we go to Web or even Art and Illustration, and then we choose a 1080p resolution, 1920 1080, right? It is simply in pixels unit, so you don't have to worry about anything. Width is 1920 pixels, which means along the width you have 1920 pixels and along the height you have 1080 pixels. And the unit is in pixels. And there is no significance of resolution right here in this box, which is pixels per inch. Because we are creating a document in pixels, so pixels per inch doesn't make sense because inch is a physical unit. And we are creating a document saying that the width is going to be 1920 and the height is going to be 1080. So where is inch there? You can put 1 here and create a document. It will have no difference. So if I try to draw something, see, the resolution is fine. If I go to File, New, same 1080, even if I put inside the resolution inside this box 1000 or even 10,000 pixels per inch, and we are creating our document in pixels as a unit, 1920 by 1080, it won't make sense because inch is a physical unit. Let's create it and it will have the same result. See, there is not much difference at all. It's the same thing, right? However, if you go to File, New, and if you choose unit as inch, so let's go to Print, right? And let's choose A4, right? A4, the unit we have chosen is millimeter. You can choose one of these presets or you can create your own. So let's say your page is a little different. Your page is of, let's say, 5 inch by 5 inch or something like that. I'm going to choose one of these presets, A4, most common type of paper. Now we know that A4 has a width of 210 millimeters, which is a physical unit, and height of 297 millimeters, which is a physical unit, right? Both of them in millimeters. We have determined it from this drop down. You can change the unit to whatever you like. Now, since these are physical unit, we need a way to relate these physical units to digital units. So we can say that for every inch have this many pixels, right? So that's what we determine here. How many pixels per inch? Because right now we are determining the dimension with millimeters, and these are physical units. They have no significance on the screen unless you define how many pixels will be there per physical unit, which is an inch. How many pixels will be there per inch? For a good print, 300 is a good number. So let's choose 300. Let's keep it at default and we're going to create a document, right? If we choose 300, look at the resolution right here. Look at the pixel resolution. Pixel resolution is 2480 by 3508, right? Let's draw something right there. Okay. Now, if we create the same A4, but we choose the resolution to be 2, very less, just 2 pixels per physical unit, which means just 2 pixels per inch. So in this inch, there's going to be just 2 pixels. And we create it. Look at the resolution, 17 by 23. See how it makes sense now? Now if you try to do something, the brush is so big, you cannot even do anything. It's a very low resolution. So if your dimension is in a physical unit, it has no significance on the screen unless you define how many pixels will be there per physical unit. If you are creating a document already, you're saying to Photoshop that it's going to be 100 pixels by 100 pixels. It has no significance no matter how high or low a number you put inside the pixels per inch box. By the way, just an FYI, it's important too. Pixels per inch, in short, is known as PPI. And in printing terms, it's also known as DPI, where D stands for dots. So dots per inch. Also, please do keep in mind that in the printing world, resolution can also refer to as PPI or DPI. So if somebody asks you, what is the resolution of this print? So you can say 600 DPI or 300 DPI, which means 300 dots per inch. So that's why it says resolution right here. This doesn't refer to the pixel resolution that we talk about, but PPI, pixels per inch. I hope by now that you have developed a fundamental understanding of what is resolution, how it works, and what are the basic ins and outs of the same. All you have to keep in mind is that resolution, and especially pixel resolution, can be a set of 2 numbers, where the first number is the width of the picture, how many pixels are there in the width of the picture, and the second number is the height in pixels as well. Resolution can also be sometimes defined as the total number of pixels. To find it, all you gotta do is multiply width and height, the number of pixels in width and height. And that's pretty much it. I hope this lesson helped you, and in the next lesson, we're gonna be talking about one of the most exciting things in Photoshop, and that is filters. So till then, stay tuned and make sure that you keep creating.